Chana, who's Managing Director of the NATO Defence Innovation Accelerator for the North Atlantic, known as Diana, and is here to tell us about a really fabulous new initiative in a talk named Diana, a multinational accelerator for emerging and disruptive technologies. So please welcome Professor Deeph Chana. Can you hear us?
I can hear you really well, Fiona. Hopefully you can hear me.
Fantastic. The stage is yours.
Okay, fantastic. Thank you so much. Well, look, first of all, it's a real pleasure to be with you all today. I think I've got about 15 minutes or so to explain a little bit about what Diana is, and then I believe there's a bit of time for a Q&A session after that. So if the slides come up, there we go. Fantastic. We can begin. So as the introduction sort of laid out, I am Professor at Imperial College London. I'm actually the incoming Managing Director of Diana. I haven't officially started that role yet. That role will start at the beginning of May. But I'm here anyway to talk to you about the project and what it's all about. So next slide, please. So just a little bit of background and context for this audience. I'm sure I don't need to introduce who this picture is, but I thought it would be interesting to put a bit of context around why we need a defense accelerator program such as Diana. I will go on to describe what that is. But after the Second World War, this is a picture of a guy called Norbert Wiener. After the Second World War, it became clear that one of the areas that was very fascinating to researchers, to technologists, was whether or not we could start creating machines, tools effectively, the next generation of tools that could be more like us, okay, that could help us to command and control systems in the world, have some kind of artificial intelligence, if you like. And really, some of this work was borne out by the work that Norbert Wiener did in the late 1940s and wrote in a book in 1948, if we have the next slide, which was entitled Cybernetics. Can we have the next slide, please? Which is, you can see the copy of the book here, entitled Cybernetics, or Command and Control in the Human and the Machine. Thoroughly recommend for those of you who have not picked up a copy of this book or read it to pick it up and take a look at it, because there is there's a real history and root of many of the subject material that we actually talk about today when we talk about autonomous systems, machine learning, AI, all these different things. But really what we end up with then from that sort of jumping point is this idea of a cyber-physical world emerging, a world where human beings and machines collaborate with one another to achieve certain tasks or certain sort of objectives in the world. And this cyber-physical system is kind of a amalgam of lots and lots of different science and technology domains. And NATO's innovation activities in recent years have kind of highlighted what some of these individual components are, which from NATO's perspective, from a defense and security perspective, need to be kind of tracked or followed with a view to thinking about how they might be used in the next generation of science, sort of security and defense implementations. And of course, this ranges from artificial intelligence to data and cloud computing, autonomy, quantum-enabled technology, space systems, manufacturing, energy. And in fact, we could keep developing this list. There's a link here on a report that was written by NATO on emerging and disruptive technologies, should you wish to look at this in more detail. One of the things we started looking at when I first started working with NATO on this idea of keeping pace with all of these different technological areas is how can we start thinking about how science and technology, which could easily kind of be used in unethical ways, going back to the last panel, how can we think of science and technology in a way that can be used in defense and security problems such that we focus on these ideas of dual use technologies? So technologies that can actually help us to drive down the probabilities of conflict and warfare in the first place, as well as the technologies that can be used within conflict scenarios to rapidly resolve them and mitigate the impact of warfare and conflict. And we call this idea is basically rolled up in something I called a more holistic kind of defense mission. Next slide, please. And we need to think in this way, really, because to not do so is to not address the fact that we are living in a world where insecurity is really kind of the fingerprint of insecurity or in problems of insecurity really is this idea of complexity, interrelated global challenges. And this is just a map that we did at Imperial College a little while ago, where I'm currently professor, looking at how various issues around insecurity, such as scarcity of water, economic hardship, and political instability, hostile threats from criminals, terrorist states, and nation states, how all of these things interrelate. Could we develop some kind of map? And, not really a surprise that what emerges is a very complicated map, and one that is actually not static and moving and is dynamic and changing very quickly as time moves on. So understanding and tackling this complexity requires this kind of world-leading science and technology that recognizes also that if we're talking about securing and defending our societies and our systems, it's not really clear where sort of the defense mission versus the security mission versus a resilience mission starts and finishes. It's a much more blurred world that we live in. And so, of course, in a cyber-physical complex system such as the environment that we're seeing kind of increasingly around the world, all of this is powered by information, data, and more importantly for this conference, I think, AI and machine learning. Next slide, please. And so in this idea of holistic security and dual use, when we look at the problem space, that was looking at the kind of the various interrelated issues. But when we look at the problem space, it's characterized by complexity, dynamic technology systems that are having increasing reach and complexity around the world, and a blurring of lines between our established isolations in our social structures. It's nice to sort of think about industry being one element and government being another, academia being another, defense being separate from security, and security being separate from resilience. But in reality, all of these things are interconnected, and there is a deep interplay between all of them. And hence this idea of dual use, multi-use technologies, just trying to expose to you the real logic of why we have to think about things in this way. Next slide, please. So let's look at some of the overarching challenges of security and defense at the moment. So we know we've got this complex interrelated world, but when we look at the way defense currently works, we find that the current systems have some issues with them. It's difficult for our defense and security entities to track these rapid developments in science and technology, to understand where the cutting edge is, and also to understand what's coming over the horizon. It's even harder to identify the priority areas for focus in this kind of complicated landscape, and then also to map out what the opportunities are, the positive opportunities are, but what also some of the big risks might be with some of the technologies that are arising, such as machine learning and AI. Problems that exacerbate some of this are, in some cases, we don't necessarily have the kind of technical literacy amongst decision makers and government bodies as would be ideal. And tech development and adoption is occurring, therefore, as an unprecedented pace outside of security and defense, and potentially what we're seeing is security and defense entities not being able to keep pace. And this graph just shows a graph of US spending in science and tech, just to illustrate the fact that the days when governments were the lead in investing in science and technology for sort of defense and security applications, or just generally speaking, housing that cutting edge defense science and technology investment, that's changing, and it's now well established that the corporate world really has most of that going on. And so how do these kind of defense and security entities keep pace with this sort of evolving environment? Next slide, please. So we started working on this a few years ago. So what could NATO do as an alliance to actually solve and address some of these problems? Well, NATO is uniquely placed, being a multinational alliance, to establish agreements and principles of responsible use for such technologies, to house innovation and coordination mechanisms, to combine the excellence of a very significant STEM-B kind of talent pool and capability that's distributed through its unique multinational membership, and to establish a transfer pipeline for technology that ensures the continuity of technical excellence for what it does. Most importantly, it's in a position to create a thought leadership proposition for holistic security and defense to attract the next generation of high caliber talent to this important area. And so we wrote some of these ideas and principles in this report that you see on the right-hand side. And again, the link is available. You can actually download this report and read it in more detail. Next slide, please. The upshot of the work that we've done over the last few years is that we felt it very important that NATO develop an innovation accelerator for science and technology, a space where it could co-develop this science and technology and learn what it was about, keep pace with it, work with industry and work with academic partners to achieve that. And so the idea of Diana was born. And Diana is an accelerator program that is designed to convene this triple helix of stakeholders of government, industry, and academia to develop and power the research and development of some of these emerging and disruptive technologies. So we will be funding through a network of accelerators this development. We will be establishing a network of prototyping and test facilities from across the Alliance in order that startups can rapidly test and assess their technologies. And we have an operational time frame where initial operations will stand up this year with full operational capacity by 2025. Next slide, please. Next slide, please. And this is just a slide to show you currently what's already kind of in place in terms of acceleration sites. So the idea here is to accelerate startups working inside those emerging and disruptive technologies. And in this map now, you can see, I won't read through it, the number of accelerator sites that are already coming online and have stood up as locations. I'm talking from one of them here at the iHub at Imperial College London, and you can see by this graph that we already, or sorry, by this chart that we already have several others, and we are expecting more to join as Diana matures. Next slide, please. Connected to the accelerators are test centers. This is very important for us to develop effectively a DevSecOps environment such that startups can go into an accelerator, can build their technologies, but then can take them to real test centers to test their capabilities, fail quickly, iterate back into the development cycle, fix the issues that they might find, go back to the test centers, and really, as I said, complete this kind of agile, quick DevSecOps cycle, which is at the heart of the proposition of Diana. Next slide, please. So Diana contains or includes several elements: the accelerator network, test centers. We will also be working on rapid adoption, so technologies can be pulled through to acquisition at a faster rate than we currently see, bringing revenue to our startups. And also the idea of a trusted capital database where capital that we feel is trusted can be listed out and made available to our startups. Most importantly here, the whole program will be orientated towards funding the dual-use technologies that I talked about earlier on, allowing startups to send their ideas and have their ideas developed and implemented in markets outside of the classical security and defense markets, as well as within them. So we're really increasing, if you like, the surface area for success for our startups, the revenue opportunities for these startups. And we're happy for startups to have success in either of those two areas or both of them. All of those things will be considered successful. Next slide, please. Allied to Diana is the NATO Innovation Fund. I'm not going to read this out in detail, but we're talking about a brand new venture capital fund, a separate organization, which will also be launched around about the same time, a 1 billion euro venture fund, the world's first multi-sovereign venture capital fund. And Diana will be giving out grant money effectively, no IP and there will be no equity take in the Diana program. And the venture capital fund will be designed to effectively allow for a transition for successful companies who then go through something like an accelerator program. They have a landing zone with a VC fund that will have an interest in being able to pick up the best ideas, invest in them, and take them to the next sort of phase of their growth. The NATO Innovation Fund is also designed effectively to attract fresh investment and new venture capital and investment into this domain of dual use, to crowd in investment, such that we create between Diana and the NIF an innovation engine, if you like, a pipeline, so that you're not just looking at a separate accelerator program with nothing to follow afterwards. Next slide, please. And so this technology engine has many features to it. We're obviously trying to become more agile, move away from administrative heavy practices towards agility and flexibility, to create a protected environment to mitigate the risks of technology loss to undesirable markets and investors. One key thing is to increase the inclusivity and diversity of the innovators that NATO attracts to the mission, this future talent piece that I talked about. And we're really talking about a game-changing proposition for a world that is being transformed by game-changing technology. By bringing entities together in the same place, we're hoping that people might collide with one another and make connections in a way that they wouldn't have before between, let's say, the triple helix elements of industry, government, and academia. And in that sense, we are sort of trying to engineer serendipity. Next slide, please. So we're pressed for time a little bit, but what I just want to stress with this slide is that actually what we're talking about here is when we talk about holistic defense, we're talking about, as I said earlier on, making sure that we can reduce the probability of conflict and warfare as much as kind of executing conflict and warfare in an efficient way. And so if we just press next slide, please. What we might do in that superset of the last slide is think about how science and technology could make that red bubble smaller, create pressure so that we're dealing with less and less conflict in the future. And so the dual use spaces that we might consider are around things like energy and security, energy security and infrastructure resilience. We've seen in the very latest conflicts how critical national infrastructure and the resilience of these infrastructures can actually make us more hardened and actually reduce the probability of huge impacts during conflict, or even mitigate the probabilities of conflict in the first place. So one of the areas that you might see us focusing is around this area of energy security and infrastructure resilience. Next slide, please. There is also the issue of the environment, of course, an enormous issue. This is a graph showing some hotspots of illicit fishing around the world, protecting our oceans, protecting our environment, whilst also having situational awareness of these different domains for security and defense applications. This is another great example of dual use where our deployments can actually help us to sort of mitigate the long-term risks of climate change, but also provide the kind of capabilities that we want from a tactical perspective. Next slide, please. And this is yet another area, the resilience of data and information systems. Of course, something of tactical importance from a security perspective, but something which is powering our everyday lives. I'll say no more than that, other than to say that this is obviously a map of some of the undersea cabling around the world that is the big infrastructure system that is sort of transnational. Next slide, please. Space, yet again, is another area where we can see huge societal transformation, global transformation coming from our use of space in the next few decades. Infrastructure systems being delivered to parts of the world that perhaps never had them before. And at the same time, we have this issue of potential militarization and the sort of security and defense elements of the use of space. So another dual use area, which again, I won't stress too much as I know we're pressed for time. Next slide, please. So just to finish off, we would like you to engage with us. We are welcoming engagement from innovators, from mentors, from investors. We have commitments around diversity and the issues which we think are very important in terms of values that we need to bake into our science and technology developments, particularly in this defense space. And so please connect with us. This is a snapshot from our website. Next slide, please. Next slide, please. And lastly, you can connect with us here. Please visit our website. Please connect with us on LinkedIn and stay tuned for some developments which will be happening in the next weeks and months as we ramp up the first phase of our Accelerator program. And we would really love to see good applications to the Accelerator program once that's up and live. Thank you very much. I'll end there.
Thank you very much, Professor Deeph Chana. Now, unfortunately, we don't quite have time for any questions, but we thank you for joining us remotely in beautiful Montreal, and it's a very exciting project, so thanks for telling us all about it.
No problem. Sorry for overrunning.
No worries. Thank you. Next up, we have another panel discussion, this time on the subject of how to build an AI-powered organization. And without further ado, I am going to welcome to the stage your moderator, Colleen Carter,